Alright, Electric Motor Division, General Motors Corporation, Maintenance Instruction, and 927 Supervision C, Lube Oil Coolers. Introduction: hydrogen lubricating oil is cooled and bypassing past water engine cooling system through the system of the tubes, the core of the width of the oil cooler, tube surrounding by with the tank with which the hot engine oil flows, with the heating of the engine oil, with the transfer of the cooling water using tube material as the conductor. There are basically two types of the oil coolers: fin tube, core type of the tube bundle, with the type of the, although the construction of the different, with the method of the cooling of the lube oil remains the same. It shouldn't be done over the major surfacing. The oil cooler should not be undertaken until the need of the surface maintenance is definitely established the unsatisfactory operation. Fin tube cooler type cooler description: cooling water enters the cool through the each of the upper head of the figure 2 with the discharge through the outlets of the lower head of the engine lube enter the cooler through the one side of the lower head and the discharge through the outlet of the opposite side of the lower head. Fin tube core type of lower oil coolers are built with either solder or mechanical type tube to header bond cleaning. When it becomes necessary to clean the oil of the cooler, the following procedures: 1. Perform the following steps to remove the tank of the oil cooler. Show the pipe nipple and nut of the tank with the mounting both lower header of the fin tube cooler type cooler, upper header core assembly clamp plate, rail assembly gasket, and lower header and clamp plate cooler core header assembly. A. Remove the water of the vent pipe nipple nut of the oil cooler. Figure 1. Loosen and remove the tank lower heading mounting bolts, nuts, and washers. C. Remove the clamp plate, nuts, washer. Figure 3. Remove the clamping plate. Shows figure 3 show the oil cooler disassembly. 1 shows the oil cooler header 2 with the gasket. 3 water inlet flange gate, 4 bolt, 5 water inlet gauge fitting, 6 O-ring, seal, 7 clamping plate, 8 clamping plate nut. Loosen and remove the bolts of the washer screw of the water with the inlet fitting with the oil cooler header with the remove the water inlet fitting and remove the tank from the oil cooler. Note: when reassemble to remove the O-ring seal with all the gasket supply with the code with the gasket sealing compound with the gasket sealing strip with the supply with the engine oil with the O-ring with the shield with the prevent with the binding of the USC using assembly 2 with the remove the upper and lower header assembly for the core with the 3 if necessary with the straighten with the header of the flange of figure 4 with the comb with the bent fins in to ensure the flow is not reduced. 4. Clean the gasket surfaces. 5. Fill soak with a tank with an undiluted non-toxic organic cleaner. See if the data level should be sufficient to allow the allow for a complete submersion of the oil cooler. Figure 4 shows damage header flange of the fins and rails. Caution: use the caustitic cleaner. If not, recommend with the fin the tube with the bond soldering or deteriorate. Will use the caustitic cleaner. 6. Soak the core for 3 hours and still tank of the tubes lying horizontally with the cleaning solution is agitated with the coat soaking in time and a half. Cleaning is more effective with the agitated tank. 7. Rinse of the core using steam water mixture. Note: rinse core as soon as possible to prevent residue from hardening. Cooling core testing. Oil cooler core failure for the other damage can be categorized under the 3 headings: fin tube with the bonding failure with the tube, failure with the tube, the head bonder failure with the repair limit in the tube with the bonding tube failures can be found. Surface data failures within repair limits of the core with the repair with the non-fusible with the core should be scrapped. Fin to tube bond check with loosened fits and fins will be heat with the heat transfer with the following step of the check with the fin to tube bond with the oil cooler should be scrapped if the loose of the fin air with exceed the limits of the surface data using a suitable tube to provide the check with the fin tube bonding, but generally pressing against the fin collar. Figure 5 on the fin move. The tube is stationary. The fin is loose. Checking the fin tube bond. Repeat steps 1 for each fin. Measure the loose fitting air fin area. Repair the loose to fin bond is not possible. Leak test. Tube leaks or tube header of the bottom leaks can be accurately located using the following procedure: with an self-scaling plate with a tank on each header of the core, approximately 50 pounds of air pressure for the tube side of the core, immersed in clean water with the room temperature. Caution: avoid exceeding 50 pounds of air pressure. Higher pressure will damage core tubes. Mark tube areas of the tube headed to the bottom with emitting bubbles. 4. Qualify oil cooler by using repair with the information given in the surface data of the oil cooler should be scrapped if the tube failure exceeds the repair limits. 5. For repair procedure, refer to the tube repair and tube head bond repair sections depending on the nature of the leak. Alright, tube repair. Tube leaks are repaired with the sealing with each end of the defect of the tube with the top, with eliminating it from the surface. Experience has shown up that 2% of the tubes can be sealed by this method without adversely affecting the efficiency of the information given in the surface data of the guidelines determining whether the core is scrapped or repaired with the recommended with the heat typically melting with the old cider with the preparing with the new cider is listed in surface data with the procedure of the both cider with the mechanical tube tube of the header with the type of the bond solder of the tube is caused for the following. Proceed with the tube. Thoroughly dry the inside of the tube with the repair. Pinch one end of each effective of the defective tube with the clove. Use the brass clove to clove the tube with the mechanical tube. The header of the type of the bond and cores. 3. Clean the tube with zinc chloride flux. C. Serve the data applying flux medium flame over the flux. Serve it over the heating with the boil over the flux. Thus, improving the cleaning ability. Using soft with the wire brush with the scrub clean of the air of which are being prepared with solder of the 4 when tube is cleaned with the soldering or is the pinch plug the end of the tube within 50% of the 50-10 with the lead. Soft solder at 470 degrees Fahrenheit. Flame C. Serve the data. 5. Flush each solder tube to avoid trapping unused flux inside. 6. Thoroughly dry the inside of the tube. 7. Turn the core solder opposite end of the tube as described above. 8. Clean the flush tube with both the headers with water. 9. Repeat leak test to ensure all leaks have been eliminated. Tube to header of the bond repair. Majority of the tube to header bond leaks occasionally outer of the tube of the rows along with the long side of the header with the low less common leaks in metal tube rows are also possible. The procedure intended to be used on solder bond type of the oil cooler cores with the cores which have the mechanical tube to header bond but do not be repairable using the method of repair procedures similar to both outer middle tube row with the primary difference between the area with the old solder with the melt of the outer tube that requires the solder removed from the only of the 2 outer tube row on each side of the core with a total of the 4 tube row with the middle of the tube rows failures to require the entire area of the solder with the header to be melted out. Recommended heating tip of the melting old solder and applying new solder is listed in the service data while repairing the tube header with the bond failure with the critical with the head to be kept in position with the square with the tubes cocked. Header will cause load on the tube to header bond causing a premature failure. With repairing the outer tube with the row failure with the header with the held square with the solder with the has not been removed with the metal tube with the row with the repair of the metal tube with the row failure with the clamping fixture figure 6 should be constructed to hold the head square within where the repairs are needed. Outer tube row repair. Leak detected with the first 2 outer tube rows may be repaired using the following procedure. With the core resting on both the head of the flange of the tube in a horizontal position, melt the side of the first 2 with the outer tube rows. Near surface of the core is resting in the cross and shows the header clamping fixture. Cross the hatching and figure 7 indicates area with the side with the remove of the melting side with the playing it at 620 degrees Fahrenheit over the area with the melted side with the run out of the dish over the header flange out the 2. B with the turn cover core over with the 2 unmelted rows of which are over the top of the nearest for the surface of the core is resting with the repeat steps. A with the clean surface with the solder with the zinc chloride flux. C surface data use the syringe to ensure that all the cracks and tubes the header surface have been cleaned with flux. Note when applying with the flux may play a medium flame on the flux surface of the heating of the boil with the flux with the improving the cleaning ability using the soft wire brush to scrub and cleaning the areas with the being and prepare for the resoldering. D. Repeat step the using the cleaning flux. This will remove any remaining dirt flux. And 2 with the core resting on the one head of the tube to the vertical position. Run a length of the number 7 1/8 of inch diameter silver shutter wire rod along each of the tube row with the C service data. Use 620 degree flame with the sweat with the solder into the tube with the header joints when the solder stops using running. Use the small amount of the flux of wire with the brush to reclaim the area. Apply solder for the gap between the header and the first tube row. Use a 3/8 inch tri-bar with the puddle solder with the strip of the data for the 500 degrees frame with a build up of the puddle with a minimum depth of 5/32 of an inch blind with the increasing depth of the 1/4 inch of the edge of the header dish. D. Solder space between rows using a 1/8 inch wire puddle solder. Surface data at 500 degrees flame. Blind excess solder at 500 degrees flame carefully so that it runs leveled out. Make certain that the old and new puddle solder is well blended. F. Remove all traces of flux and immersing with the core several times in the cold water. Repeat leak test to ensure all the leaks have been eliminated. And figure 7 show the oil cooler schematic. Middle tube repair. Following the procedure of the repair, leave the middle tube row with the construct of the clamping fixture. Using the dimension figure 6, the clamping fixture will keep the header square with the core with it being repaired. 2 bolt each half with the clamping fixture with the core headed flanges. 3 with the core retesting both header flanges of the tube with the horizontal position. 8 melt the old side of the tube with the header of the melt solder playing with a 620 degrees flame over the entire area of the solder to remove the melted solder to run out of the dish over the head flange out. B. When the solder has been removed, the clean also with the reduced solder with zinc chloride flux and with the surface data using a syringe ensure that all the cracks in the tube of the header surfaces that have been cleaned with flux. Note when applying flux by a medium flame of the flux surface, the heating of the will boil the flux into improving the cleaning ability. Use the soft wire brush to scrub and clean the area with the being of the prepare for the soldering. So you repeat steps to B with the using cleaning flux with this will remove any remaining dirty flux. Perform steps 2 and 3 under the outer tube repair. Alright, tube bundle type cooler description of the water UV the cooling loop, figure 8 and 9. Water's UV the cooling lube oil enters through the flange connection. One header flows through the tube. The end is charged with flange connection of the opposite of the lube enters the shell of the space of the flange connection. You have the one end of the cooler flow with transversely around the tubes and baffle with the discharge through the flange connection. You have the other end of the cooler, the water lube oil through the cooler, opposite of the direction, produce the maximum cooling effect. Show the header, the shell on the header. Tube bundle type oil cooler. Show the cutaway of the view of the tube bundle type oil cooler. Baffle. Show the tube bundle oil end hub. Cleaning when it becomes necessary. Cleaning the oil cooler with following procedure: 1. Remove the header from each of the cooler. 2. Caution you with the caustitic cleaners. Not recommended. The bonding solder would deteriorate with you with the caustitic cleaners. 2. Fill soak with undiluted non-toxic organic cleaner with the surface data of the level should be sufficient to allow for the complete submersion of the oil cooler. 3. Soak with the cooler for 3 hours and still with the tank with the tubes lying horizontally. If the cleaning solution is agitated, cut the soaking time in half. Note: cleaning is more effective with the agitated tank. 4. Rinse core with the extinct water mixture. Note: the rinse the cooler as soon as possible to prevent residue from hardening. Tube leak test. Tube leaks are accurately located to use the following procedure: remove the header from each of the end of the cooler. Seal off one of the lube oil inlet openings. Apply low pressure air to the remaining lube oil inlet. Immerse cool water in the tank containing clean water at room temperature. Determine the mark where the bubbles are. Mitigate air bubbles. Note: occasionally a leak will develop around the tube end of hub bond. If the air bubbles emit from this area of the cooler, should be scrapped. 6. Qualify the oil cooler using the repair limited information given under the surface data. The oil cooler should be scrapped if the tube layer failure exceeds the repair limit. Is preferred with the tube repair with a repair procedure. Tube repair. Tube leaks were repaired by sealing each end of the defect of the tube with a solder, with eliminating from experiencing it has shown up to 2% of the total tubes can be repaired by this method without adversely affecting the efficiency. Solder tubes closed using the following procedure: thoroughly dry inside the tube with a repair. Clean the defect of the tube with zinc chloride. Flux surface data with applying flux of the plate at a medium flame with a flux surface of the heating wheel with the boil with a flux, improving the cleaning ability using soft wire brush to scrub of the cleaning areas which are being prepared for the soldering. 3. When the tube is thoroughly clean, insert the brass plug into each end of the defective tube. 4. Soldering the plug with the tube with up to 50% of tin, 50% lead, soft solder, and it's 470 degrees flame. See surface data. 5. Clean and flush cooler with water. 6. Repeat tube leak test to assure that the leaks are eliminated. Surface data. Specification: fin tube coil or loose to fin tube bond. Total area not exceed 15 square inches. Loose fin to tube bond. No single area to exceed 10 square inches. Tube repairs. Maximum number of adjacent tubes repaired 4. Maximum percentage of the total number of tubes repaired 2%. The tube bundle type of cooler. Tube repair. Maximum number of adjacent tubes repaired 4. Maximum percentage of the total numbers of the tubes repaired 2%. Equipment: solder software 50. The tin lead 1.5 bar. Solder tri-bar 40% tin, 60% lead, 25% bar, 25 pound bar. Solder silver wire 2.5% tin, 97% lead, 0.5% of silver, 1/8 diameter, 25 pound spool. Solder spool 38% tin, 62% lead, 1/8 inch diameter, 25 pound spool. Flux zinc chloride 1 gallon can. Cleaning solution: Quaker solvent cleaner 76, cellulone tricolor ethylene or octite number 31. Heating tip stainless steel available to the National Cylinder Gas and Blowpipe Company under PN 727-813N. Alright, that was Electric Motor Division General Motor Corporation MI 927 Maintenance Instruction Lube Oil Coolers.